All right, class. Everyone, this one is going to be a lesson on how to convert decimals into fractions. And so the first thing that we need to understand about a fraction is decimal place and their values. So what does all of that actually mean? Now, we're probably used to hearing things like this. This would be our ones value. This would be our tens value. Okay? This would be our tenths. This would be our hundredths. And the 7 would be our thousandths. Okay, so anything that ends with a DTHS, you know is going to be on the right side of the decimal. Anything that just ends, well, I guess with just the S. I can't even say that. But these are our whole values. As the numbers increase on the left, the whole value becomes larger. As we move to the right side though, each number that you see right here actually becomes less value. Their values are not nearly as high. However, I'm going to explain that to you in a moment because let's just go over this rule right here. If we had 1 over 1, we have one whole. That's 1.0, or in other words, 100%. Okay? That's the same thing as 10 over 10. That's going to give you one whole, 1.0, and 100% once again. Doesn't really matter. In our one wholes, though, right here, that's 91, our whole values, our denominator will always be 1. So we got, in our ones value, we got 1 over 1. 1 over 1 is still a whole number. In this case, though, this is our tens value, so that's 90 over 1. Because we have 9 tens, which would give us 90, which is 90 over 1. But what about something like this? We now move into our tens. So we have to realize this. As we move to our right side, or our left side, we're increasing our number by a magnitude of 10. Now, by saying that doesn't mean that 7 has a higher value than 5 on the thousandth spot versus the hundredth spot. In fact, the opposite is true. As you go further to the right, the values actually decrease. But our denominator increases by a factor of 10. Okay? And let's just start off from the decimal. 1 times 10 is going to give us 10. Okay? For this is going to be our hundredths value. Oh, how did I get 100ths? Well, because 10 times 10 is going to give us 100. And then our next value is going to be our thousandths value. And how did we get 1,000? Well, we took that 100 and we multiplied it by 10, and that gave us our thousandths. So it's not really a coincidence that we see our 10 fraction right here, our denominator of 10, as our tenths, our 100 being our hundredths, and our thousandths, or our 1,000 being our thousandths value. Now I'm just going to take out that little ghosted image there. Now, how do I better explain this? Okay, so when we have a whole number of 1 over 1, we understand, is 1.0. But when we go 1 over 10, well, that is actually the equivalence of 0.10. Okay? As we move over to the right, to our hundredths place, well, that's 1 over 100, and that equals 0.01. When we go to our thousand, that's actually 1 over 1,000, and that's going to equal 0.001. So as you move to the right side, our values are actually getting smaller, but the magnitude of our denominator is increasing. But let's go back to our fractions. If we keep our numerator constant, but we increase the denominator, that means that our value gets smaller, right? You shoot one free throw, or sorry, you shoot 10 free throws and you make one, well, you got 10%. But let's say you have 100 free throws attempts and you only made one, well, that's 1% now. Okay? So the other thing is, if you don't understand that part, here's another way we can explain things. If we have $1, that's $1, right? But you have a dime. You would need 10 dimes to make one whole dollar. And if you remember the penny, well, that's 1 cent. Well, you need 10 pennies to make one dime. You also need 100 pennies to make $1. So is it a coincidence that this is also the 100ths? And the answer is no, it's not a coincidence. You know, it kind of sucks. They got rid of the penny. Yeah, it makes sense economically. It costs more money to make that penny than it's actually worth. But it also makes teaching math a little bit more difficult because in a few years from now, I don't know if kids are even going to know what a penny is anymore. But this is what I mean by, as we move to the right side of our decimal, the value actually gets smaller. But it is the denominator. So the magnitude of our denominator increases by a factor of 10 every single time. So do not confuse that as you move right, the numbers are actually getting bigger, because that is not true. Okay, so let us start off with something like this, 0.375, all right? We want to turn this into a fraction. So all we really need to do is count our decimal places. There are 3 decimal places, that's 10, 100, that's 1,000. We can simply say, you know what? Our denominator is going to be 1,000. We are simply going to put the number that we see up here, and that's 375. 375 over 1,000, if you put that into your calculator, it's going to give you 0.375. And if you want to turn that into a percentage, you're going to move that decimal 2 places to the right, and that's going to give you a grand total, or a total percentage of 37.5. Okay, now if you have a number like 0.350, okay, now you might just be saying this, oh, Mr. Tat, this is going to be easy, right? Our denominator is over 1,000. That's not true in this sense, because as we put a 0 right here, this actually has no effect on this 0.35. I can technically add an infinite number of zeros and it wouldn't matter. All we're going to do here is we can just completely get rid of that 0. In fact, we get rid of every single 0 right here. So we're just left with actually 2 decimal places. That's 10, that's the hundreds. There you go. You got 100 and you've got 35 at the top. So let's just do a little bit of a review. We understand that every 0 on the right side does not, as long as the last digit is not a, or is a 0, it doesn't actually affect the total value of this number right here. It's kind of like you can put an infinite number of zeros in your whole numbers. This 0.00075 is the same thing as 75. It doesn't matter how many zeros I put in here, the value is still the same. But we don't ever write our numbers actually like that. However, when it's the decimals, the opposite is true. It's zeros after the right side where it doesn't actually affect the value. Of course, this is significantly different than these 2 numbers right here in terms of value. Okay? The opposite is true. The zeros in front, immediately to the right of the decimal, actually do change the actual value. Okay? Now, one thing is, we talked about having an infinite number of zeros at the end. Well, you can also have a 0 in the middle of a decimal number. For example, 0.83. Okay? We just assume that there's infinite number of zeros from here on, so we don't even worry about that. But we have a 0 right here. It doesn't actually matter as long as the number immediately on the right side is greater than 0, This is totally acceptable. So we got 1, 10, 100, 1,000. Our denominator is going to be 1,000, and we're going to go 6,803 over, sorry about that, you know what? 10, 100, thousands, 10,000s. This denominator should be 10,000. And if you put that into your calculator, you're going to get 0.6803. And if you want to convert that into a decimal, same thing as always. You move the decimal 2 parts to the right, and you're going to get 68.03%. All right? Now, last but not least, the last thing that I want to show you is this right here, 1.475. Okay, so 1.475. Now, you're probably not used to seeing things like this, okay? 1.475 just implies that you have one whole. But it's exactly going to work the exact same way that we've always done this. There are 3 decimal places, so you know that it's going to have 1,000 as our denominator. All right? That rule does not change ever. But because you have one whole, which is 1, that's the same thing as me saying that I have 1,000 over 1,000. But we have the addition of 475. So decimal 475. All we're going to do here is we're going to go 1,475 over 1,000. Okay? All we've done here is we've dropped the decimal, and we've just written the numbers that we see here. And we know that it's over 1,000 because there are 3 decimal places. Now 1.475. We want to turn that into a percentage. We just move that 2 spots to the right, and that's going to give us a grand total of 147.5%. Now, if this is some sort of investment return, well, you are definitely a happy person. But